guys, this is Victor from Florida. We want to introduce you to EIGRP for IPV4. This class is you're really going to enjoy it, and it's going to be a little bit challenging for you. But stay focused and stay happy because you're really going to have some fun doing this kind of exercise of EIGRP for IPV4. Guys, have an excellent day, and I really hope that you enjoy this class. Hi guys.
Hello guys, this is Victor from Florida and I am over here to help you with some labs about EIGRP. Basically, this is this lab over here. I found this lab on Cisco Network Academy. Basically, I am going to show you how I want to do this kind of lab. It's very interesting because it looks like a game to me. It's quite challenging. It's not a boring IT technology that you found on a lot of stuff like programming. No, this is something, a challenge to your mind. It's like a puzzle. When you get a lot of puzzles, you put the whole picture together, and you're gonna enjoy some fun with everything that I'm gonna teach you right now. But there are three things that I want to make sure that you understand. I want to make sure that in this lab over here, all these bit values over here is 0/0/0. Way too long. It's gonna be S0/0. That's it. The other one is gigabyte 0/0. Guys, if you're a regular guy, a regular Joe that can handle a regular job, and you're over here to learn, so assuming that you are not an expert in that kind of stuff, and you're not playing with a gigabyte Ethernet that is for a very high speed and with a lot of capacity, and you didn't pay for three battery, each one costing you $2,000. I want you that you focus on this kind of stuff, and I'm gonna be teaching you as a regular basic, as a regular person, and not with fiber optic whatever. So that stuff is out. The third thing, and it's probably the stuff that you're gonna like the most, is that these classes that I'm gonna give you, and a lot of times you're gonna be spending time typing a lot of stuff over and over and over, and I don't want that happens because you're gonna get boring. And if this exercise is gonna take about 10 minutes, 10, 15, 20 minutes, it's gonna take 2 hours for you if you start typing all that kind of stuff. I don't want you to get bored typing over for 2 or 3 hours. I want you to understand the concept, and once you do that, you are on your own and you can do the typing or not. But you will understand that first before be typing over and over. So let's start rolling over and let's start playing a little bit with this kind of stuff, guys. So over here, this is what I mentioned over here, as you can see in the graphics, the gigabyte Ethernet 0.0, how it appears over here, the S0/0/0, no, S00. It's a little bit confusing, but by the side you're gonna see the IP address, and then on the other side you're gonna be the subnet mask. On the subnet mask, you're gonna see certain difference. Let me show you real over here on my graphic over here. No gigabyte 0/0. It's gonna be gigabyte 0/01. Faster Ethernet. I mean, S-0/0/0. No. It's gonna be S0/0. Easier for you. Over here on the subnet mask, you're gonna see over here 252 and 252. I mean 255, 255, 252, and 255, 255, 255. That's 0. 252 correspond to the 30 cider mask, and that's the way that I subnet. 252 cider mask of 30. Easier for me. I don't need to do calculation. It's way easier. I love that way because I don't have to do anything. I know that you probably know a very specific way. Guys, personally, on my own opinion, try to memorize, try to play a little bit with this table. If you don't know how to do that, just email over here and I'm going to explain how to do that, and it's going to be way easier to know which cider mask you're going to be using. So over here, you see on the second row over here, it's going to say 255, 255, 252. We're talking about cider mask of 30. Everything that I'm telling you is over here in this part. One more thing. There are three things that can happen. First of all, we could have been using packet tracing. That's a simulation. Second, we could be using a DNS tree. That's emulation. Third, we would be using real equipment. Yes, great. But what happens with real equipment? You wouldn't see the graphic. And guys, it's essential that you see the graphic so you're gonna know what are we doing right now. So come with me, and I'm gonna show you how to do this exercise. So guys, thank you for coming over. This is GNS3. Try to download it. I just put a couple of stuff, a couple of routers and a couple of switches. It's gonna be a little bit similar to the stuff that you saw over there on the graphic. So let's try to configure. The reason that we are gonna configure is that it will take the proper interface. Please check what I am doing right now. So now let's connect the interface that is gonna need. Boom. S00 from here. We're gonna put it to X00 from R2. From here again, S0.1 port, serial port, to the S00 port of R3. From here, S001 to the 00/1 from R2. Now from the rest, S01 each one of them. Power to everything. Basically a couple of stuff that I already mentioned, guys, is over here. I don't need to repeat that. Besides that, there is disable DNS lockup, a couple stuff. I know that you have done this in previous exercise and to password stuff like that. I don't want to pass that situation, and I want to jump, so it wouldn't be too difficult for you. So you wouldn't spend a lot of time doing something that I'm pretty sure that you already did a long time ago on your first classes or CCNA. So let's go to console. Enable. Boom. And excellent. We've done this exercise on R1. Now let's jump. Look how fast it was. And you didn't take about 15 minutes doing that kind of stuff. Copy. One more thing. You see over here, 128,000 clock rate. That's where your DCE is located. Remember the graphic that I showed you guys. Console. And everything is up, as you could see over here. Eventually, I want that you check the values that we put over here in each one. Everything is over here on the addressing table that I show you guys. Double check them very well and look how everything is gonna be configured on the graphic that we put over here. So let's start working with the last one. Console. Everything down. So we come over here. Boom. Everything is up. Excellent. Now that we are over here in R3, let's do a small exercise. Why don't we try from R3 to get to this value for R3 to get to 10.3.3.1 and 10.2.2.2. You see from R1 and R2, those are the places where we are going to. Let's do it. We could pin. Excellent. I am very happy because of that. Now let's check the other one. Pin the value for that 10.3.3.1. Boom. Guys, I hope that you'll be following me in this exercise because this is getting very interesting. Now we see over here, guys, that the part 2. We already did the verification. And now we're going to be jumping. We verify the connectivity through the pin. And we're going to be jumping in the part 2 that is configuring the EIGRP routing. The first stuff that we're going to see over here is that we're going to enable EIGRP on R1. And we're going to be using the autonomous system number 10. So let's jump in on that right now. First thing, we're going to take this value, copy, and after that we're going to be using console, and the mode is conf t. From here we're going to do copy and paste, and we got this stuff running. Over here we're going to advertise this network. Check over here how we advertise the network. It's gonna all of them 10.1.1.0. Over here is ending in 0 over here, the first 4 octets, and over here is ending in 0 as well. But the number over here is 0.0.0.3. And you say, wonder why 3? How come this is happening? Where this number is coming over? This picture crazy? No, remember that you have a mass of 252. 255 minus 252 is 3. And what happens with the other one, 255, is the whole stuff. You got the whole number, 255 over there, because that's why you need to reach that is your wildcard mass, the whole 255 number. So you know where it's coming from. Now you know what to do with it. We're gonna do copy, and we're gonna do a paste. Boom. So guys, this part over here it says, why is it a good practice to use a wildcard mask when advertising the network? Well, it's a good practice to advertise the network that you gonna be using, the network that you're gonna be accessing, the network that you can control. And you're gonna see that over and over when you gonna ask for to show a display of the protocols and everything. So right now you don't know how to use it, but eventually you're gonna see how important that is. That's it. That depends on how bad do you need it, how you're gonna need it, how you're gonna use it. Could the mask have been omitted from any of the networks stemming above? If so, which one? The wildcard mask could have been omitted from the network 192.168.1.0 network stemming because EIGRP will assume the 0.0.0.255 classful mask that I was showing you previously, guys. So let's check out what else do we have. Enable IGRP routing advertise directly connected networks on R2 and R3. So you're gonna see the sensing message when we will do that. You haven't seen that sensing message because, of course, certainly it was on their own. So let's check this out. Copy to make your life easier. Off T, I'm sorry. Boom. I just sensed it, guys. Do you see it? Right away. It was really quick. And now let's go over there. There is the message that you're getting right now. And now let's double check with R3. Copy. We see some adjacency, guys, and that's excellent. So right now, we're gonna verify the connectivity over here. Give me 2 seconds, guys, and I'm gonna explain you how to do this. So let's try to verify this. We should ping each other. Okay, I'll do that. Let's check it out. From R3, I'm gonna try to ping 10.1.1.2. Let's double check that. Guys, this was successful. I don't want to go all over each one of the interface, but I want you that you see the fact that you can. It was forming the neighbors with the other and the adjacency with the other stuff over here, and it could ping and it could see the whole scenario, all the other routers that we have over there on the table. So guys, now we're gonna part 3. We're gonna be verifying the EIGRP routing, examining the EIGRP neighbor table. To do that, we're going to R1 and we're gonna check this command over here. So from R1, you're gonna see your neighbor over here through the 10.3.3.2, 10.1.1.2. Then basically, if we go over here to the graphic, you're gonna see these values over here. Hold on, give me 10.1.3.3.2. That is the one on R3, and 10.1.1.2 that you're gonna see on R2, guys. You see it? Hopefully you are. So after having this, we're gonna be checking the EIGRP routing table with this command, show IP route EIGRP. By the way, you see over here, I didn't mention before, but these are the serial, the ones that go to 0/1 and 0/0. Over here, you're gonna see something interesting, guys. The, the most interesting part is that it got two ways from R1 to get to 10.2.2.0/30. That is the same thing at 255, 255, 255.252 for the reasons that I showed you before. And you wonder why we have this situation over here. The situation is because we have an equal cost balancing. That means that it takes the same stuff, the same effort to get to 10.2.2.0. You can go in either one of these two paths over here. You got only one path to get over here, you got only one path to get over here. But you got two paths to get to 10.2.2.0. Examine the EIGRP topology table. Let's do that right away, guys. So let's jump in these waters. Boom. What do you see over here? Well, this is going to be a very interesting stuff. You are going to see over here a couple stuff in this scenario. 10.2.2.2.0. You got two ways to get over there, and you got two successors. Two ways to get over there, because equal cost path that balancing that we just mentioned recently. But over here, we have only one successor, one successor, one successor, one successor, one successor, and one successor. Remember, as I mentioned, it have equal cost balancing over here in this exercise. So in the next stuff that we are going to see over here, verify the EIGRP routing parameters and network advertise. What is it? Okay, let's double check what they're talking about. So, what do we see over here, guys? We see over here the first value that is by default. This is the bandwidth. The second value is 0, and the third value is 1. Then default is delay. You can see over here the maximum hop count is 100, variance is 1, redistribution EIGRP 10. And this is all this information is gonna be very important when you do redistribution, guys. We're gonna see over here routing for the networks 10.1.1.0, 10.3.3.0, 192.168, 1.0. That means that you're advertising this network, guys. This is gonna be a question over here in this lab, and I want you to understand that very, very well. And over here is one of the most important stuff. The distance of 90 of EIGRP is way smaller than what you could find on the OSPF, and smaller than you can find on RIP. So knowing this information is very important, and this is the reason why it was very important that we advertise our network, guys. So the question over here is, what autonomous system number is used? We are using the autonomous system 10. What networks are advertised over here? Well, the networks that you see over here, let me put it over here so you're gonna see that right away, are this one over here that we were talking about: 10.1.1.0, 10.3.3.0, 192.168.1.0, guys. The next question, what is the administrative distance for EIGRP? Well, we saw that stuff, didn't we? It was 90. How many equal cost path does EIGRP use by default? To get an answer for that, let's get back to R1. Maximum number path 4. You see it? Yes, it is. Okay. So let's get back to the exercise. Configure bandwidth and passive interface. EIGRP use default bandwidth based on the type of interface in the router. Part 4, you will modify the bandwidth so that the link between R1 and R3 have a lower bandwidth than the link between R1 and R2 and R2 and R3. Why are we talking about that? Because we don't want to have an equal balancing as we did before. So we're gonna be switching the information, so it could have some preference in case that you want to redirect that, and you're gonna be using that for future exercise. So stay with me, guys. So step 1, observe the current routing settings. Show interface at 0. Hold on. What do we see over here, guys? We have an NTU of 1500 bytes. We got a bandwidth of 1544 kilobytes. We got a delay of 20,000 microseconds. All this information is going to be very useful and very important for you, most specifically when you're doing path control and redistribution, guys. You're going to see that over and over and over. So try to get used to see that kind of stuff. So we're taking the correct setting over here, guys. When we put over here show interface S00, the NTU 1500, the bandwidth 1544 kilobytes, the delay 20,000, reliability, that's low, and all the rest of the information. So the information that they're asking over here basically is what is the default bandwidth for this serial interface. Bandwidth is over here, as you can see, guys, 1544 kilobits per second. And the other information, how many routes are listed in the routing table to reach the 10.2.2.0. Well, we already talked about that, guy. It's gonna be two different because we have right now two equal low cost balance to reach that route right away. Step 2, modify the bandwidth of the router. We're going to be modifying the bandwidth of the router right away, guys. We're going to get this information, copy and paste. See how we modify the bandwidth over here. So now that we have this information, let's start working with that. Now, on step 3, we're going to verify the bandwidth modification. So, verify the bandwidth notification, issue R1, show interface 0.0.0. Okay, let's do this. You're going to see the value over here of 2000, as we mentioned before. The delay of 20,000, as we mentioned before. NTU, 1500 bytes. We get the number, the 8. Based on bandwidth configuration, try and determine what the R2 and R3 routing table will look like before you issue a show IP route command. Are they routing tables the same or different? We're gonna check that out right now. What we see over here is that in R2 we have the same routing table as before, because we have two equal cost routes to 10.3.3.0, the one that you see over here, guys. You see this one and that one, that's equal cost. Now, let's check on R3. So what we see over here is that from R3 we have a 10.1. There is only one path over here. You see this, guys? Only one path to get to R2. That only one path to get to 10.1.1.0, and that part is via R2, and it happens because they have a bigger bandwidth, guys. So I want you to understand this. The situation is different because we did some modifications to the bandwidth. So let's double check something else, guys. So guys, the next part of this exercise is configure F0/0 interface as passes on R1, 2, and 3. So let's start jumping over here. We're gonna see over here R1 router EIGRP 10 passive interface F0/0. So it happens the same thing on R2 and R3. So I'm gonna start doing all of them at once, and you're gonna see the results. So we finished doing this project. Let's double check show IP protocols. So we see a variance of 1 over here. When we got this information, I have the whole information at once. You're gonna see the passive interface over here, fast Ethernet 0.0. So guys, this exercise is almost done. So guys, the last part over here is gonna be reflection. It says you could have used only study writing for this lab. What is the advantage of using EIGRP, guys? Well, we saw over here a couple of stuff on EIGRP was very useful, and the advantage over other kind of protocols. I think that one of them is first, it's very fast, as you could see over here. Second, the convergence is really that's something that weighs a lot. Third thing is because it can have you can have summarization, and summarization means that you have a variable Sunday mass. Remember that we have over here 252 Sunday mass and the classful Sunday mass that was 255 at the end. So because you have a classless and classful Sunday mass, that gives you the flexibility to be playing a little bit with that, guys. So that's something that you need to waive as well, depending on the Sunday mass of the network that you have over there. And I guess that one of the most important thing as well that I would say, guys, it would be that it have equal low balance all over the place, guys. So as you saw, it have equal low balance, and you gonna could be playing with that stuff as well, in case that we want to prioritize the network and the path that you have. So guys, thank you very much for watching. Thank you very much for paying attention to this lab, and I hope that you enjoy it. In case that you need that you have any kind of question, don't hesitate to ask. Have an excellent day and keep in touch, guys. Bye. Bye.